Hello. Today we are going to talk about chemical reactions. Chemical reactions occur when atoms or elements rearrange themselves to form a new substance. The five types of chemical reactions are synthesis, single displacement, double displacement, combustion, and decomposition. Using different kinds of methods, we will prove these five types of reactions with follow-up tests to prove the products were formed.
Synthesis is defined as the integration of two or more pre-existing elements which result in a new creation. Here in our synthesis reaction, we will be synthesizing calcium oxide, simply distilled water. Pour the distilled water into a beaker, and then taking the solid calcium oxide, scoop out 2 full scoops. Be sure to do this in the fume hood with the fan on because solid calcium oxide with contact on the skin may cause irritation. After mixing the calcium oxide in the water, simply take a litmus paper and then dip it into the beaker. To show that calcium hydroxide, the new product, is a strong base, the litmus paper should turn a dark blue, showing that calcium oxide and H2O has synthesized. Our next reaction is single displacement. Single displacement is when one element appears to move out of one compound and into another. Here, we will be taking prepared 1 molar HCl liquid and putting it into a test tube. Taking a solid magnesium strip and putting it into the test tube, a reaction will occur by noticing that H2 gas bubbles will be formed. By capturing the H2 gas bubbles with a test tube that will be placed directly over the original test tube, we will be able to do a gas test to show that H2 has been produced by doing a lit splint test. By taking off the test tube from the top of the test, by taking out the second test tube that's on top of the test tube where the reaction is occurring, simply take a match after removing the top of the test tube and placing it directly under the other test tube. You will hear a pop, and listen carefully to the one that happened in this experiment as it is very quiet. Our next reaction is double displacement. Double displacement is when two compounds switch the cations and anions to form two different compounds. Here, we will be having one reactant compound being sodium carbonate and another barium nitrate. Normally, they are left as solid in room temperature. To form them into a liquid form, simply take out about 1 full scoop and putting them into half a beaker of a 50 ml beaker. You should mix the solution until all of the solid has been dissolved and then there is none left and is simply a clear solution liquid. Using heat to quicken the dissolvement was not recommended, so it is best to simply stir it at room temperature.
Now we're going to mix the two.
Taking a third large beaker, add the two solutions into the larger beaker.
And now the sodium carbonate.
Immediately, as the second one is added, you will see a white precipitate formed from the two solutions being added. To notice that the product has been formed, waiting overnight, you will realize that the two different products will settle. The white precipitate on the bottom will be barium carbonate, and the solution layer on top will be liquid sodium nitrate.
The top will be sodium nitrate.
Our next reaction is combustion.
I can directly take it from
Combustion is a complex sequence of exothermic chemical reactions between a fuel and an oxidant, accompanied by a production of heat or both heat and light in the form of either a glow or flames. For our combustion reaction, we will be taking solid potassium chlorate, KClO3, and putting it into a test tube.
like that.
By heating the potassium chlorate over a Bunsen burner, you will be able to decompose the solid to form potassium chloride, KCl, and O2 gas.
It has to be completely melted. And then put it in.
Be sure to use this
should
in the
be
flame
angled,
to
right?
avoid to take any precautions from the Bunsen burner and the decomposition of the potassium chloride. Be sure to turn on the fume hood to absorb any gases that will be produced from the combustion reaction. After lighting a Bunsen burner, decompose the solid until it melts completely. Be sure that all of the solid has melted completely. After it's melted completely, simply take a gummy bear using tongs and drop it into the solution. A bright flame will ignite, with gases being quickly thrown out from the test tube. What is happening is that the sugar from the gummy bear is reacting with the O2 gas being produced, which is known as combustion.
19.21.
Decomposition is our last reaction. Decomposition refers to the reduction of the body of a formerly living organism into simpler forms of matter. Here, mass out the test tube that will be used for the reaction.
Oh, we need 2.3.
And then, mass
That's too much.
approximately 2.36 grams of sodium bicarbonate, also known as baking soda, which amounts to about half a
A little
teaspoon.
bit more.
It does not have to be exact but
2.36,
approximate.
that's good.
After taking the mass baking soda, the sodium bicarbonate, put it into the test tube. Adding the two masses will give you the total mass of both of them before the decomposition occurs, which is important to show that the reaction occurred afterwards. After pouring all of the sodium baking soda into the test tube, using a test tube clamp, light a Bunsen burner, and heat the baking soda.
What? Don't.
Take the baking soda and put it directly over the flame. Heat the baking soda for about 15 to 30 seconds. The baking soda, sodium bicarbonate, should decompose into CO2 gas, sodium carbonate, and H2O. By taking a lid spin to show that CO2 gas has been performed, the lid spin should be put directly into the test tube and it should immediately distinguish to show that CO2 gas has been produced. To show that the reaction has decomposed and there has been a loss of matter, go remass the baking soda and test tube. After waiting for it to cool, mass it. But before mass to show that H2O has been produced, if you look carefully at the top of the test tube, you can see that H2O vapor has been collected at the top.
I can't see it. No.
After cooling, remass the test tube, and then you will notice that there has been a reduction of mass of both the test tube and baking soda, which accounts for the decomposed CO2 and H2O lost in the reaction. This concludes our 5 types of reactions lessons. Good luck.
My life be like